All right, so we are going to study what we call the mole concept. So I will indicate here the mole concept. Here we are looking at what the mole is. What is the mole? So the mole represents the number 6.02 times 10 to the power 23. Also, this number is called Avogadro's number. So this one is called Avogadro's number. So this number was determined from the number of carbon 12 atoms in exactly 12 grams of carbon 12. So they took 12 grams of carbon 12 and then asked themselves how many atoms are in 12 grams of carbon 12. So they found 6.02 times 10 to the 23 atoms, and they called this number Avogadro's number. So what does Avogadro's number mean? It tells us that one mole of atoms is equal to 6.02 times 10 to the power 23 atoms. So if you have this number of atoms, you have one mole of atoms. The same thing, one mole of molecules is just the same as 6.02 times 10 to the power 23 molecules. And then we have one more of formula, which we'll see later. Formula units is equal to 6.02 times 10 to the power 23 formula units. So one more of anything has that number 6.02 times 10 to the power 23. So if you ask, what about one more of people? The answer is yes. One more of people has 6.02 times 10 to the power 23 people in it. So let's see if we can solve some problems based on the mole. Let's solve an example. How many moles of hydrogen are present in 7.4 times 10 to the power 23 atoms of hydrogen gas. So what you need to know is the solution. We know that 1 mole of hydrogen gas is equal to 6.02 times 10 to the power 23 hydrogen atoms. So that is the conversion factor that we are going to use. But you also need to find what is the given factor or the given quantity. So the given quantity is given in the question. So this one is our given quantity. So when solving this problem, you start with the given quantity times the conversion factor. So the best way is to do that by cancelling units. So I will start with the given quantity, which is 7.4 times 10 to the power 23. But we are saying atoms. So I have this number of atoms. So as usual, I will draw my line here, and then I also have atoms down here that covers this part, and then I'll have more. Because the unit, one side it has atoms, the other side it has moles. Now the side that has atoms has the number 6.02 times 10 to the power 23. The side that has more has just 1 more. So when I calculate based on this, I find that my answer is 1.2 more. So this is to 2 significant figures, because this question has 2 significant figures here. So you just multiply the given value times the conversion factor, but you need to follow the units. If you have atoms up here, you need to have atoms down here. So if you have used atoms, the remaining unit goes up, it will be a mole, and then you get 1.2 mole to 2 significant figures. Let's solve another question. How many moles of copper are present in 1.25 times 10 to the power 24 copper atoms? So as with the previous equation, we need to indicate the conversion factor. The conversion factor says 1 mole of copper is equal to 6.02 times 10 to the power 23 atoms of copper. So as usual, you look for your given quantity. So this is our given quantity, 1.25 times 10 to the power 24 atoms. So I am going to start with that one. 1.25 times 10 to the power 24 atoms. So if I have atoms here, I need to put atoms down here. Now I have used this part. I am remaining with this part, which means I need to put more up here. So in terms of more, it goes with 1. In terms of atoms, it goes with 6.02 times 10 to the power 23. So when we multiply this, we find 2.08 more, because atoms here will cancel with atoms there. And you can see that our answer is 3 significant figures, because our question here has 3 significant figures. Let's look at another problem, a third problem. Now, how many molecules? Now, these are not moles, but molecules. How many molecules are present in 2.5 mole of water? So for this question, we go back to our conversion factor. We say 1 mole is equal to 6.02 times 10 to the power 23 molecules. So that is our conversion factor. And here, your given quantity is 2.5 mole. That's what you need to start with. So I will say 2.5 mole times. So if you have more here, you need to have more down here. And if you have more down here, then you will have molecules up here. So I will say molecules. So the mole goes with 1. The molecules goes with 6.02 times 10 to the power 23. So, and when you do this calculation, you find the answer is 1.5 times 10 to the power 24 molecules. Now the mole is going to cancel with the moles here, and we just remain with molecules. On that side, let's look at our last problem. How many atoms are present in 0.75 moles of sodium atoms? So our solution, we will say 1 mole is equal to 6.02 times 10 to the power 23 atoms. So you put whatever depending on the question. Here the question is asking about atoms, which means you need to put atoms here. The previous question was asking about molecules, that's why we put molecules here. So how many atoms are present in 0.75 mole of sodium atoms? So we know 1 mole is equal to 6.02 times 10 to the power 23 atoms. Our given quantity is 0.75 mole. So we are going to start with 0.75 mole times, we are putting moles down here so that they cancel, and then atoms up here. So the atoms go with 6.02 times 10 to the power 23, and the mole goes with 1. So when you do the calculation, your answer is 4.5 times 10 to the power 23 atoms. So these are the two types of questions that you need to answer based on the mole and the number of particles, number of atoms, or number of formula units. So let's look at something else. Molecular mass. So molecular mass and formula mass. So what is molecular mass? So by definition, molecular mass is the mass of a molecule given in atomic mass unit. Probably it is the total mass of all the atoms present in the molecule. So for example, what is the mass of C6H12 and O6? We are looking at the molecular mass of that. So our solution, because we have 6 carbon here, so we are going to have 6 times mass of carbon, plus we have 12 hydrogen there, 12 times mass of hydrogen. Then we have 6 oxygens there, 6 times mass of oxygen. So these masses, we are going to obtain them from the periodic table. So here, the mass of carbon is 12.01. The mass of hydrogen is 1.008. And the mass of oxygen is 16.00. So this mass must be given in atomic mass unit. When you add all the masses, you get 180.16 atomic mass unit. So that is the mass of C6H12 0 or O6. Another definition. Formula mass. So what is formula mass? Really, this is the mass of one formula unit of an ionic compound. So that is a formula mass. So it is calculated from atomic masses of its components. So an example is calculate the formula mass of aluminum oxide. So for this one, we have 2 aluminum and 3 oxygens. So we are going to say 2 times mass aluminum plus 3 times mass oxygen, which is 2 times the mass of our aluminum is 26.98 plus 3 times the mass of oxygen is 6.00, which gives us 101.96 atomic mass unit. So that is how we determine the formula mass and also the molecular mass. So one thing to take note of is that formula mass and molecular mass are given in atomic mass units. So let's look at another mass, which we call the molar mass. So what is the molar mass? So this one is the mass of 1 mole. 1 mole of an atom, a molecule. Or a formula unit. So its value is the same as molecular mass. So its value is the same as molecular or formula mass. But now what is different is that it has units of grams instead of atomic mass units. So but it has units of grams instead of atomic mass unit. So if you ask a question, what is the molar? What is the molar mass of H2O? So for this one, the calculation is the same as molecular mass, but this is now molar mass for 1 mole of water. So we are going to have 2 times mass of hydrogen plus mass of oxygen. Now this one is 2 times 1.008. Now it should be given in grams plus 16.00 grams. Now this gives us 18.02 grams. So since it's a molar mass, it should be grams per mole. So each mole of water has 18.02 grams. Let's look at another problem. What is the molar mass of C8 H10 Ne4 and O2. So for this one, we are going to have 8 times mass of carbon plus 10 times mass of hydrogen plus 4 times mass of nitrogen plus 2 times mass of oxygen, which in this case is 8 times 12.01 grams plus 10 times 1.008 grams plus 4 times 14.01 grams plus 2 times 16.00 grams. So since this is mass of 1 mole, we are going to have 194.20 grams per mole. And you can see our answer is to 2 decimal points because we are adding, and our smallest decimal points are 2 decimal points. So that's what our answer is. So that's how we determine the molar mass of a substance.